plane curve. So plane curves can also be represented in vector notation. Basically, it's like a plane. I think that's all it means is like an actual full shape like that. This one's in 2D. And so even if it's 2D, you can still graph it as vector notation. So for instance, the curve given by the parametric equations x equals t squared minus 2t and y equals t plus 1. So this is in 2D. See my earlier video, and here's screenshots from my the calculus book notes on it. So this is from an earlier video. Can also be described by the vector equation. So here's just this just recall my earlier video first. This is x equals t squared minus 2t, and then y equals t plus 1. If you graph it out, it looks like this, and goes from here. It goes from here all the way up like that. Just a horizontal parabola there. Yeah, but now we're going to write this in vector notation. So what we're going to get is, well, r of t, this equals 2. Well, now just write these in components. So the first one is the x one. There's t squared minus 2t. Minus 2t, and then the next one, this one is 1 plus, or t plus 1, like that. And this is the same thing as just writing it as in 2D, so this is going to be 2t, t squared minus 2t. This is going to be I plus, and then this is going to be t plus 1 plus 1 j, like that. And in this case here, because we're dealing with 2D, this is where I is equal to, this is just going to be the standard basis vector 1, 0. It just follows along the x axis, and then j vector is equal to 0, 1. Like that. And here's just a quick recap from my earlier video, or recall from my earlier video, that I, j, and k are standard basis vectors in 3D, but if you just have I and j, that's just in 2D. So what we'll have is standard basis vectors. Here's 3D. And the whole idea is if you have a vector a right here, you could just multiply it by the standard basis vectors, just any constant a1, a2, a3, times it by this one here is going to be 1, 0, 0, j is 0, 1, 0, and then k is 0, 0, 1. So just multiply it by those like that. Anyways, and in 2D, you just remove the k variable, or the k vector. Anyways, let's take a look at example 4. And this one asks, sketch the curve whose vector equation is r of t equals to cosine t times I plus sine t times j plus t times k. So let's take the k vectors. So let's take a look at the solution. So the parametric equations for this curve are, so we're just going to write x equals to cosine of t, then y is going to equal to sine of t, and like this, then and then z is equal to t, like that. All right, but one thing to notice is that since we have this x and then y are just cosine and sine, well, since we know that, well, x squared plus y squared, this just equals to, if we just square those, that's just equals to cosine squared t plus sine squared t, and this is just the Pythagorean identity, or this Pythagorean identity. This just equals to 1. Yeah, and what this means is, well, then the curve must lie on the circular cylinder x squared plus y squared equals 1, and it's a cylinder because basically t is any value. So I mean, z is any value t, and that just goes up. That's just the vertical axis. So you draw a circle and it goes all the way up and down. So the point x, y, z lies directly above the point x, y, and 0. So in other words, just above it. So it's the vertical cylinder, which moves counterclockwise around the circle x squared plus y squared equals 1. And that's because as when you plug in 0 right here, cosine squared 0 plus sine squared 0, this just becomes 0. And then as you increase it, this is going to be positive. So in other words, when you increase from the x and y, and it depends on which how you have the axis aligned. If you have x and y like this, it's going to go counterclockwise. So going further, so which moves counterclockwise around the circle x squared plus y squared equals 1 in the xy plane. The projection of the curve onto the xy plane is a vector equation r R of t, move some room right here actually, like this, has R of t, let's leave it like that. And I just see my earlier video on this. So the projection of the curve on the xy plane is vector equation R of t cosine, equals to cosine t sine t, like that. And basically, I'll move it like this. This is the projection of that equals to this right there. And you can see my earlier video on this. And again, I went over this earlier in my earlier video when you just have cosine t. So if you have a point right here, let's draw this right. This is a point right here. This is our x. And yeah, that's our x, this is our y. In other words, this is just our cosine and t. And then if you square those, that's just a circle there. So you just have a circle like that. So anyways, long story short, that's just a circle from my earlier video. Because x is cosine t sine t, this has to be, and then using Pythagorean identity, equals to 1, the squared, so then it's just a circle. So since z is equal to t, the curve spirals upward around the cylinder as t increases. Yes, because this is a projection onto it. This is when t is equal to 0, or when z is equal to 0. So when you set z equals to 0, it's just flat on it. But then as your z is increasing, so for example, even though it's still going in a clockwise there on the projection, it's actually increasing more and more as z is increasing. So then the curve spirals upward around the cylinder as t increases. The curve shown in the figure below is called a helix. And so here I'll just graph how it look like. So it's gonna have a cylinder shaped like this. Let's draw the cylinder first. So for now, first all I'll do is draw this the z component, and it's gonna be now in a cylinder like that, and it's gonna go straight down like this. Draw this, finish off the cylinder like that, and this goes like this. This is the y, this is the z, and this is the x, like that. I'll draw this for completeness all the way down. Actually, let's draw this first one, I guess. So this is at the point 1, 0, 0, and I think that's where it starts off at. Yeah, it starts off at here, because if you plug in 0 inside here, 0, cosine t is going to be 1, sine is going to be 0, this one's 0. So it starts off here, and it's going to go around in a circle, counterclockwise. So there's the y is going to go counterclockwise like this. And at this point right here, this is, it's going to be on this point right here. This is 1 there. So it's going to be 0. Now x is 0, y is 1. And now the question is, what is what is z? And if you look at right here, so this goes from here all the way to, this is at 0, 1. So in other words, it goes, t is pi over 2. Yeah, then that's a full 90 degrees. So that is t is equal to 90 degrees. Yeah, pi over 2. Or 90 degrees. And again, we already written this down there. So that's already done it from my earlier video. And so in other words, this is going to be pi over 2. That's our z. In other words, that's the height here. That's the height is pi over 2. Like that, yeah. And then it's going to continue on. It's going to circle around like this. I should make it a better circle. Like that. I should make it really light. Like this. It goes around. And then it circles back in dark. Like this. Whoops. And then circles back in light like that. And I'll make it dark like this. And so on, like that. Yeah, so it just goes, circles around like that. And I'll draw this for completeness, all the way down, dot, 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 and all the way across like that. And there's our y like that. So that's how it looks like. Yeah, it's pretty good actually. I was surprised myself. And yeah, here's a better illustration from my calculus book, which is again I just copied. There's the there's a cylinder. Starts off at 1, 0, 0, and it curls around. But basically, it's curling around in a circle, counterclockwise circle, but it's also going upwards because of the z parameter or the t, and that increases this pi over 2, and so on, goes up and up and up and up. like that. And also here what I've done is I've graphed it on GeoGebra's 3D graphing calculator. There's a link to it. And there's a cylinder x squared plus y squared equals to 1. That's just to graph the cylinder. And now you can graph it as a curve. So this cylinder right here, if you just put it like here, it assumes the t values are the z value is infinite. So it just draws a full cylinder, and you can see it wrap completely around it. And this is the curve cosine t, sine t, and then t. And I made it just up to 6 pi, so 3 revolutions. And so on, looks like that. So pretty fascinating stuff. I'm going to go, here's the link to it. And you can hide it. There's a cylinder. There's a curve. And you could play around with it, and so on. Yeah, it's pretty epic stuff there. Zoom in and zoom out. And there's the top. Yes, top is a perfect circle. And again, just goes up because of the Z parameter. So fascinating stuff. And here now we'll just take a quick look at the DNA helix. So the corkscrew shape in example 4, this one right here, just corkscrews around like that. Yeah, this is familiar. It's familiar from its occurrence in coiled springs, and it also occurs in the model of DNA or deoxyribonucleic acid, the genetic material of living cells. In 1953, James Watson and Francis Crick showed that the structure of the DNA molecule is that of 2 linked parallel helixes that are intertwined, as in the figure below. So it's similar to that shape here, but now there's 2, and they're intertwined with these base pairs inside like that. So there's a double helix. And here's more info. So here is more info on DNA and RNA from my earlier videos, and here's links to them. And I just put the screenshots that I made because they're pretty epic screenshots. Yeah, so DNA is contained in the nucleus of every cell of the body, or at least most of them, and so on. I'm not sure the specifics, but anyways, so this is generally the case. So here's RNA is basically is a single strand typically. This is typically double strand DNA, and then these are the base pairs right here, or these are these are the base pairs that that line up. Or the these are nucleobases, and they line up with each other. Here you have cytosine. So for RNA, you have the CGAU, so cytosine, guanine, adenine, and uracil. And this one's the same thing. You have cytosine, guanine, and then adenine, except uracil, you have thymine for DNA. And then there's the corresponding match right here. This is the red one matches with the yellow. Red, yellow, and so on. And then this one here, yeah, these are base pairs. So helix of sugar phosphates, and so on. And here is there's a cell. So if you have an animal, it has a bunch of cells, and each cell, if you zoom into each cell, you go to get the nucleus, and inside there you have the chromosome, and inside the chromosome you have basically a giant spiral of DNA like that, and it's like that. So it's pretty fascinating stuff there. So that's like the genetic code. And here's another diagram. This is a central dogma of, here, I'll just fix that up. So central dogma of molecular biology states that the information flows from DNA to and from RNA to protein, and never from protein. So you can get one DNA to another, then you can go to RNA. So you can go from here to here, and you can go backwards in some cases, like reverse transcriptase enzyme and so on. But typically it goes from DNA to RNA. So our DNA creates RNA, and then RNA creates the protein, and it never goes reverse. Biology states that the essential dogma of molecular biology states that information flows from DNA to from RNA to protein, and never from protein. So it does not go from here to the reverse. And here is a more detailed diagram of the molecules and the base pairs, and so on. So here's pyrimidines are on this side, purines on this side, Ag, there's Tc, and so on. That is different phrasing for them, and they line up with hydrogen bonds like that. And there's some more info on this, how these are some, these are the exons. This is the RNA layer. It cuts off the RNA, go back here. So you have the DNA, and then it goes, we have a protein there, or this ribonuclear protein SNRP goes and basically duplicates from here. It creates an RNA. First it creates like this, then you have other ones cut off. The introns are the cut off ones, and the exon is what's left over, and that's the mature RNA, only exon. So it cuts off all the excess and other bits of it, and so on. Anyways, you get this generally like that, a mature RNA from this DNA, and so on. Yeah, so that's the mainstream biology.